Let's discuss about these features in more detail. First feature is default and static methods in interfaces. From Java 8, interfaces are improved to have a method implementation. So first is default method. A default method is a method defined within an interface with a default implementation. It is used to provide a default behavior. They are denoted by default keyword. Default method allow interface author to add new methods to existing interface without affecting the classes that already implement the interface. Classes that implement the interface can choose to override the default method. Default methods are typically used for backward compatibility and to avoid breaking existing code when new methods are added to interfaces. Let's talk about the static method. Static method is a method defined within an interface with static keyword. Static method not related to any specific instance of the interface and can be called using interface name. They also provide utility methods that are related to interface but don't depend on instance state. Static method in an interface are similar to static method in classes, but they are accessible through the interface itself. Now let's see some code example for these two features. So friends, let's see the example of default method and static method. This is an interface named as test interface. This is the abstract method, which is a normal interface method. And this is here, we can see this is our default method. So default method has used the keyword default and it is a default method. We can see in our implementation part, we don't need to override our default method. If we want to override default method, we can override default method also. So this is the implementation of default method and we can override this method also here. If we don't want to implement, we can ignore that and we can just keep the implementation in our test interface. After that, we have static method, and if you want to call the static method, we can simply just call our test interface and we can call our static method directly. We don't need to initialize the interface or implementation class to call this static method. We can directly use our static method instance and we can call the static method. After this, let's go ahead with our next topic. Now let's talk about function interface and lambda expression. Function interface is an interface that contains only one abstract method. It represents a single function contract and can be considered a blueprint for a lambda expression. Function interface are annotated with @function interface annotation to indicate that they are intended to be used as such. Remember, function interface is not compulsory. It's just an indicator that you cannot add more abstract function in that interface. And one abstract method is compulsory in a function interface. Let's see some example of function interface. Consumer, it is an operation that accepts a single input argument and returns no result. Predicate is an function which takes one argument and return a boolean result. Function is a function interface that takes one argument of type t and return a result of type r. Now let's talk about lambda expressions. A lambda expression is a concise way to represent a single method interface, that is function interface, by using a simple inline code. Lambda expression allows you to define and instantiate function interface without creating any anonymous class. They make code more readable and expressive, particularly when working with function style programming construct. Some benefits of using lambda expressions are lambda expression can reduce boilerplate code and make code more concise and easier to read. Function interfaces and lambda expression allow more flexible and expressive API design. Also, Java becomes more suitable for functional programming paradigm and simplifies working with collection and stream because of Lambda expression and function interface. We will see some code example for these feature also.
So friends, in functional interface example, we have an interface math interface. We have annotated it with the @ function interface, and it has one abstract method, calculate, which takes two input a and b and returns a type of integer. Now let's see the example for this function interface. So this is the implementation of math interface class. Here we have the Lambda example for the same interface. We are calling it as addition Lambda. It is taking two input and returning the addition. So here we are implementing calculate method in Lambda form. Now let's see one more example for subtraction. In this I am calculating the subtraction of a minus b. So this is called as subtraction. Here is the Lambda example of subtraction Lambda. Here I am passing a and b and returning the difference of a minus b. So here in addition I am calling the function calculate. Same for subtraction, I am calling the function calculate. Same thing we can do in Lambda also. Addition Lambda dot calculate, subtraction Lambda dot calculate. So here we can see the example of functional interface converting into Lambda function. So we can see that how much number of lines is reduced in Lambda. So this is the major function given in Java 8. After this, let's see some more interface example in Java 8. These interfaces are inbuilt interfaces in Java 8, which represent functional interfaces. So first one is function, which takes input type of t, which takes input type of t and returns type of r. So in this example, I am creating a function string length, which is taking a string as input type and returning integer as response type. So in this, it is calculating the length of string. So that's why the function name is string length. Function interface has abstract function apply. That's why we are calling string length dot apply and passing hello world. Its response will be 12. After this, we have consumer interface. Consumer interface takes a type of t and returns nothing. Consumer interface has accept as an abstract method. Here it is taking a type of string and printing that string, and I'm calling the string dot accept function here. So it will print printing hello world. After this, we have predicate example. Predicate has abstract function test. Here we have written an example of is-even function. It is taking of type t and returning a boolean value. So I am calling is-even test for 4 and is-even test for 7. So it will return me true or false. So these are boolean response for this function. So here is the response of these function interfaces. You can pause the screen to check the examples. Also, you can see the GitHub link for these examples in the description section. Now let's move to our another topic.
So the most important topic is Stream API. Java 8 has introduced Stream API. So what is a stream? A stream is a sequence of elements that can be processed in parallel or sequential. Remember, Java provides support for parallel as well as sequential streams. Stream are not data structure. Very carefully listen that. Streams are not data structure, they are just computational concept. Stream are designed to be concise, expressive, and often more efficient than traditional loops. So some feature of stream is pipelining. You can chain multiple operations in a single pipeline. Now second is laziness. Streams are often evaluated lazily, but the element are processed in streams as needed. So this leads to better performance. Immutability: streams do not modify the source code. They create new streams with desired transformations. Let's see some key operations, that is filtering. We can filter data, we can map one data to another data, that is transform it. Reducing: we can reduce the data by using some methods like sum, max, min. We can collect data into a list or set or any as per our requirement. We can group and partition data. We can sort data with the help of these operation streams. Let's see some code example for stream also. For stream API example, I have wrote some code for you guys. So here's the example of empty stream. Empty stream we can write on stream class. So this will give us an empty stream, and we can count this stream, so its response will be 0. After that, we can write a collection stream with the help of arrays.aslist method. So I am passing a comma b comma c. If I count this stream, its response will be 3. After that, I can use function find first in stream API. So this will give me an optional object, and on that I can call get method. This will give me response A. In stream, we can also create parallel stream. So here is a stream of integer from 1 to 150, and I'm using a parallel stream, so it is giving me a parallel stream of integers. I can check that the stream is parallel or not with the help of is parallel method. This response will be true. After that, I can do filtering on stream. Here I have a list of fruits. I am streaming on that list of fruits, and I'm filtering out a fruit which has starting letter A. So in this starting letter, for A is for apple, and then I'm again returning that filtered list into a list with the help of collect method. So this filtered list will give me a response of list of apple. After that, I can do mapping on stream. So here is a list of hello comma world. I'm mapping it into uppercase. So this capitalized word list will give me this hello world in capital letters. After that, I can use the reduce function in stream. So this reduce function will create a sum of these numbers, and it will give me some of these numbers. So in all these examples, we have seen different functions we have used in stream. So this is called pipelining in stream. So here's another example of pipelining in stream. Here are the response of each stream. After this, let's move to our next topic. Let's talk about for each method, especially in iterable interface. In Java 8, for each method was added to iterable interface as a default method. It avoids creation of iterable code. We do not need to write that for code for an object or for I iterable. We can just directly use for each method in a single line. It is a convenient way to apply a certain operation to each element of the collection without the need of for explicit iteration. For each function is a consumer kind of interface. So it takes something but doesn't return anything. We can provide a lambda expression, a method reference, or an anonymous inner class to define the action you want to perform. Let's see some code example for each method also. In Java 7, we have seen for each example many times. For example, this is a list of fruits. I'm creating an array list of string, and I'm passing some fruit names in, and then I'm iterating it over and printing the fruit name here. So for reducing the effort for each function in iterable interface, this for each function is added by default. So now we don't need to write this iterable function. We can directly write for each for our list or any collection. So this is the example of for each in iterable interface.